Let us take some problems on method of variation of parameters. Method of variation of parameters is a very special method to determine the particular integral of higher order differential equations. Particularly, the rules are extremely simple when we deal with second order differential equations with constant coefficients. Question number 1. a0 y double dash plus a1 y dash plus a2 y is equal to f of x is a given differential equation with complementary function c1 alpha x plus c2 beta x, where c1 and c2 are arbitrary constants. If the particular integral is a times alpha x plus b times beta x, what is the expression for b? This is a question. This is in fact a formula based question. Without derivation, we can just look into how b is determined. In fact, alpha x and beta x are independent solutions. We can determine what is known as the Wronskian determinant with alpha x, alpha dash x in the first column, beta x, beta dash x in the second column. When alpha x and beta x are independent solutions, the Wronskian determinant will always be non-zero. Now, without going to the theory, the formulas to find out a and b are well established formulas. A is equal to minus beta x fx by wx dx. Beta is integral alpha x f of x by wx dx. Since we are talking about b, you will find this formula for b appears as option B in your solutions. Question number 2. Y double dash plus 4y is equal to tan 2x is a given differential equation, and the particular integral, if it is given as a cos 2x plus b sin 2x, what is that b? Now you can assume that cos 2x and sin 2x are independent solutions of this differential equation. So we can say alpha x is equal to cos 2x, beta x is equal to sin 2x. Let us work out the Wronskian as determinant. First column, alpha x and its derivative. Second column, sin 2x and its derivative. Expand the determinant, you will get 2 cos square 2x plus 2 sin square 2x, so it is 2. Now we know the formula for b as integral alpha x fx by wx. Alpha x is cos 2x, fx is this right hand side, so it is tan 2x by wx is 2. So cos into tan will give us sin 2x. Integration of sin 2x is minus cos 2x by 4. So this will give us minus cos 2x by 4. So this is the expression for b, which matches with option D. Question number 3. Differential equation y double dash minus 6y dash plus 9y is equal to e power 3x by x squared has a particular integral of the form a plus bx e power 3x. What is b? Very similar to the last problem, but the integration has to be done carefully. Now we can easily see that alpha x and beta x can be read from the structure a into e power 3x. So alpha x is e power 3x, b into x e power 3x. So therefore beta x is x e power 3x. Now let us find the Wronskian. The Wronskian is first column e power 3x and its derivative, second column x e power 3x and the derivative of this. If you apply the UV rule, you will get 3x plus 1 e power 3x. Expand, you will get 3x plus 1 e power 6x minus 3x e power 6x. After simplification, the Wronskian is e power 6x. Now, as in the previous problem, b is equal to alpha x fx divided by the Wronskian. Alpha x is e power 3x, fx is this right hand side, divided with the Wronskian, which is e power 6x. If you simplify, you will get the integration of 1 by x squared. The integration of 1 by x squared is minus 1 by x. And this appears as option C in the problem. The differential equation y double dash minus y is equal to e power minus 2x sine e power minus x has a particular integral a e power x plus b power minus x. What is b? So you can see the independent solutions are alpha x e power x, beta x e power minus x. So the Wronskian determinant will be e power x and its derivative, e power minus x and its derivative. So you will get minus 1 minus 1, which is minus 2. So b is equal to integral alpha x fx divided by the Wronskian. Alpha x is e power x, fx is this right hand side, so e power minus 2x sine e power minus x by the Wronskian is minus 2. So if you simplify, you will get minus half e power minus x sine e power minus x. Substitute e power minus x is equal to t minus e power minus x dx is equal to dt. So you will have minus half integral sine t into e power minus x dx is minus dt. So this is half integral sine t dt, which is minus cos t by 2, which is minus cos e power minus x by 2. So this is the determination of b, and this option you can find as option D in the solution.